So observe in last class, we all studied what is work done and what is work, what is the units of work done and all. So if you notice what is the formula for work done, everybody, work done is equals to what?
Displacement, sir.
Force into displacement. That is what we have been studying. And what is the units of work done? Everybody, units of work done is equals to
Joule, sir.
joules. Understanding? Joules are what is the CGS unit? CGS unit is year. Yes. So and we know that 1 joule is equals to, if we have taken 1 Newton into 1 meter. So that is what we have been studying the relation. And same way, 1 joule is equals to how many ergs? 10 power 7 ergs. Is it right or wrong? Now, if you notice it, if we are applying the force exactly parallel to the surface like this or like this, then work done is equals to force into displacement. That is what we studied in the last classes. Now, as we know, it is not possible to apply the force exactly parallel to the surface. For example, if this is the toy car or car, normally, you might remember, if the force is applied like this direction, then if it is shows the displacement, we will say work done W is equals to force into displacement. But as we know, a boy who is pulling the car, toy car, is it possible to apply horizontal to the surface every time, everybody? Is it possible to apply horizontally? No, he cannot apply the force horizontally. So that we all knows that a boy who is pulling the toy car, he will apply the force with a certain angle. Is it yes or no? That is what the angle between the surface and the direction of applied force. So this is the direction of force and this is the direction of displacement or motion of the car. Now, the angle between them is only we used to called as theta. So in this case, what is the work done? Formula. Anybody? We studied in the last class. What is the work done? Everybody. So work done W is equals to open your mouth, interact, communicate. What is the formula? Harish? F.
Sir, horizontal or vertical, sir?
Fs cos theta. Is it right or wrong? Now this cos theta, I have given you the values. Theta 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and as well as 180 degrees. So 180 degrees today I will teach you like types of works. By the time you will understand. So what is the theta is equals to 0 degree? What is the answer? Cos theta. All of you. But I told you
One,
one. 30 root 3 by 2. 45 1 by root 2. 60 how much? 1 by 2. And 90 0 and 180 minus 1. That is right. So, if I have taken any kind of surface, Mr. Harish Dera and everybody listen, this is the most important concept. If I have taken any kind of surface, if I apply the force perpendicularly to the object, now tell me, is it any displacement will be there? That is what my question. All of you. If I am applying the force perpendicularly to the object or surface, is it any displacement in the body? All of you? No, because in this case, what is the angle between the surface and the applied force? All of you?
90 degree.
90 degrees. So, in this case, total work done is equals to how much? Everybody? Zero. What is the total work done? 0 joules. Any doubt, anything in this, ask me. Understand, Mr. Harish Jairas, Kaushik, Aswin, Nimish? Please kindly respond. If it is any doubt, ask me. So, if I am applying the force perpendicularly to the surface, then always the work done, total work done is equals to 0. Because let me take how it will be. Suppose, for example, see W. Now, force, let me take, I applied 100 Newton force. Now, 100 into. Is there any displacement in this case? I want the answer. Is there any displacement in this case? Displacement is equals to what? 0 meters. So 0 into what is the angle between the surface and the object? Force applied force. Everybody? What is the angle? Cos 90. Yes or no? So work done W is equals to 100 into 0 into cos 90. What is the cos 90 value? Check it, everyone. 0.
0, sir.
Which is equals to anything into 0? 0 only. So total answer is how much? How much work done? Work done is equals to 0 joules. That is what you have to remember. Clear? Hari Somar? Akilan? Okay. So that is now, as I told you, when the object is moving like this, understanding motion is like this and applied force is like this, then what is the formula here? Everybody have to take. W is equals to F S cos theta. When it is work done is equals to horizontal component. All of you remember, motion will be like this. This is horizontal component or vertical component? Harish? Horizontal component. Understanding? Work done is equals to horizontal component of force, horizontal component of force into displacement. Then the formula is Fs cos theta. If it is vertical component, all of you, if the body is moving like this direction, see that all of you, I am applying the force in this way. This is the direction of force. Now the displacement will be in this way. Then tell me what is the answer? What is the formula work done? Fs W is equals to what will come? Fs sin theta. That is you have to remember. This is vertical component. Vertical component and this is horizontal component. Clear? Anything doubt? Ask. Now, if you are clear with this, then in our today's class, we are going to study types of work. So let us discuss what is this types of work and how it will be happening. So I hope you are all clear with that. Horizontal surface. All of you remember, if you have taken horizontal component, so what is the formula for work done? Everybody? Yes, please. Horizontal one. What is the component? What is the formula? Work done is equals to Mitakshri. W is equals to Fs
Cos theta.
Clear? So now, sorry, you want picture. If it is a horizontal component, you can take, for example, if this is the object now at point A. Let me take everything I will draw. So this is the point A. Now consider this is what my object. Now I am applying the force in such a way, just I am pulling. Let me take Mr. Harish or Harisera, somebody is applying the force and here with some angle. So this is the direction of motion. Is it right or wrong, everybody? Is it right or wrong, Akilan? This is the direction of motion and this is the direction of applied force. Direction of applied force and this is the angle between them. Now, after certain time, it has been changes into the position. This is the position which I have been changed the object. Object is reached here. Okay, everybody, guys. This is the object A and position A. And this is the position B. Now tell me, I want to calculate the work done. So what is the formula will come here? See that. Displacement is horizontal or vertical. So it will come F cos theta. So what is the work done formula in this case? All of you? Work done W is equals to what is the formula? F into cos theta. Is it okay? Harish? Harish? Yes? Yes or no?
Yes,
Response.
sir.
That is what. Now, let us go to the, if you'll understand this concept, so all of you remember, even for class 9, you have only formula, work done is equals to F into S. More than this, you don't have. But types of work is there. Types of work means positive work done. Negative done. So that is why, in that cases, we need this one. So that is the reason we have to study this also. Now, observe very carefully. Please mute yourself, please, Omar. Omar, being a disturbance. Okay. Now, observe very carefully. Now we are going to study positive work done That is what we will say first type of work done. All of you keep it. Anyone having any doubt in today's class, please ask me. Surely I will explain it. Slowly we'll go. Today we are going to study types of work done. This is the most important concept out of whole chapter, which is very, very necessary for your higher classes also. So types of work done. So let me take first. Remember, depend upon the angle. Depend upon the angle. Angle means what? Anyone? Applying the force. That is what theta. Depend upon the angle between, okay, depending on angle between force and displacement. Force and displacement. So work done will be classified into three types. So first one is positive work done. What is that, Harish? Positive work done. Second one is negative work done and negative work done. And the last one is called as zero work done. Zero work done. Is it okay, guys? Please respond. Negative work done, positive work done, and zero work done. So let us discuss what are the things is happening and what is the examples we people can make. This all for positive work done, negative work done, and zero work done. Shall we start now? Everybody, are you clear? So it is based upon only one. What is that? Anybody tell me? Either the work is positive or work is negative or zero work done. Only based upon one thing we will say. What is that, guys? Here, check it. What is that point? Reason behind it? You have to respond.
Angle.
Between the force and displacement. That is what will decide what is what type of work done. Now, let us come to the first. Positive work done. Everybody keep heading. Mitakshri, are you understanding? Positive work done. Anyone having doubt, you can ask me. Positive work done. Now listen. When the angle between the force and displacement is acute angle. What do you mean by acute from mathematics? Let me see who will say. Harizeras, Gokul, Arun. Yes. When the angle, all of you listen, when the angle between the force and the displacement is acute. What do you mean by acute? All of you should tell me.
Less than 90 degrees, sir. Less
Angle
than 90
Than
degrees.
90 degrees, sir.
Angle where is from where to where? Yes, please.
0 to 90, sir.
From 0 to 90. That is the most important. Means you must write acute. Means angle is varying from 0 degrees theta to 90 degrees. Is it okay, everybody? This is the most important for MCQs also. 90. Then work done will be positive. Then work done will be positive. Is it okay, guys? Yes, please. I want the answer.
Yes, sir.
Read out. That is now. So if you notice it here, in this case, the cos theta values will be positive or negative. All this 0 to 90. Verify the tabular column. All these cases, cos 90, cos 0 to 90, all the values are positive or negative. Verify it here. Yes, please.
Positive.
Positive. Understanding? So that is also you have to remember. So in this all the cases, in this case, cos theta will be positive. Write it. In this case, we have surplus time. You please learn at a time. Cos theta is positive. That is what it is. Now tell me less than 90. So if you take for example, this is the surface and I place the object here. All of you observe, this is the object at point A. Now, this is what actually from the center we will consider. So I'm applying the force like this. This is the direction of force. Direction of force. Now tell me this angle is less than 90 or greater than 90 or what it is. And displacement will be like this. This is the direction of displacement or motion, I will say. Okay. Now tell me, is it a positive work done or negative work done or what it is? All of you.
Positive work done, sir.
Positive work done. Why? The angle is what? Angle is less than 90 degrees. Understanding? So, for example, if I consider if theta is equals to 0 degrees, then can you tell me, Harish, what will happen value? Cos theta is equals to how much? Cos 0 degrees is equals to how much value? Tell me. Cos 0
1,
is
sir.
1, sir.
all of you. Cos 0 value how much, guys? Cos
1, sir.
1. So, what is the work done formula? What is the work done equals to? Everybody. So, work done W is equals to Fs cos theta. So, cos theta means it is 0 degrees. Fs cos 0. So, that formula will become what? F into S into 1. Because cos 0 is 1. So, finally, work done is equals to what? Work done is equals to what? Force into displacement. That's all it is. So this is only we have for class 9 for your NCRT. Only work done is equals to force into displacement. Are you clear, everyone? Any doubt? So in between 0 to 90, for example, this value I have given as a 45-degree angle. I am applying the force at 45 degrees angle. Then tell me what is the work done is equals to? If theta is equals to if theta is equals to 45 degrees, then what is the answer? Cos 45.
1
Cos
by root 2,
45.
sir.
Yes, Harish?
1
Cos
by root
45, how
1 by
much
root.
amount?
1 by
1 by cos
Root
45.
2.
1 by root 2. Is it yes or no? So what is the work done? W is equals to F into S into understanding cos 45. So cos 45, which is equals to F into S into 1 by root 2. Is it yes or no? All of you? So what is the answer will come? Whatever it is, the W is equals to 1 by root 2 into F into S. Is it right or wrong? All of you? Yes?
Yes, sir.
If theta is equals to 60 degrees, then what will happen? All of you. Theta is equals to 60. Verified answer. Theta is equals to 60. I
1
want
by
1 by 2, sir.
yes. So cos 60 is equals to 1 by 2. Then work done is equals to what? Verified all of you.
1
Fs
by 2
into
displacement.
cos 60. Cos 60 degrees, which is equals to F into S into 1 by 2. Now, work done is equals to others also should respond and you have to answer. Work done is equals to, can I write Fs by 2? Is it right or wrong? All of you verify it.
Yes, sir.
Yes, other. Now, can you tell me if the fourth is the angle? Have you noticed it? If the angle is increasing from 0 to, if theta is increasing from 0 to 90, then 90 as we know work done is equals to 0. Understanding? But remaining cases less than 90. So amount of work done is decreasing or increasing. Check it everybody. I want the answer from you all. If theta is 0, work done is F into S. Now theta become 30, theta become 45, theta become 60. Now work done is decreasing or increasing? Hari? Amount of work done. That is the result I want from you, your mouth. All of you, Mr. Kaushik, Hari Zeras. Check it everybody. So which is better? Applying force horizontally or with some angle? Which is easy to push the object or pull the object? Which is easy, horizontally or with some angle? That is what my question. All of you. Suppose this is the car. This is the car. Now I am applying the force exactly parallel to the surface. This is what? So theta is equals to 0 degrees. Now this is the car. In which case you people can pull the car easily? Tell me. This is now 45 angle or 60 angle. Now tell me in which case you people can pull the car easily? All of you?
In the first case, sir.
First case, Asai, Hari. How Hari? Here work done is equals to, here work done is equals to F into S, Hari. Here work done is equals to F into S divided by root 2, Hari. So which case the work done is less, Hari?
Case 2, sir.
Second
case
case,
2, sir.
You understand, Harish?
Yes, sir.
For example, let me take, in this case, applied force is, observe very carefully, applied force is 100 newtons and displacement will be 2 meters. 100 newtons. Now totally work done, tell me how much it is, everybody. Work done is equals to partly 100 into 2 equals how many newtons, how many joules? 200. So now same thing you apply here. Same some force I applied. Work done is equals to 100 newtons. Sorry, force is equals to and displacement is equals to 2 meters. Now if I apply the work done, which is equals to how much? 100 into 2 divided by root 2. So what is the answer will come? So let it be, I will remove the root 2, or else you can make 200 divided by root 2. What is the value? Root 2 value, tell me. Root 2 value is 1.414. So do it and tell me what is the answer will come. 200 divided by 1.414. How much will come? Fastly. Omar, no response.
141.
200 divided by 1.414.
141.4, sir.
Yes, 414. If you have taken approximately, you will get 144. Is it yes or no? So now tell me total work done. Which case less? 144 joules. So in which case the person will become tired more? Case 1 or case 2? You should answer. Case 1 or case 2? Even I am proving with the values. Mr. Omar, which case will be doing more work done? Case 1 or case 2? No response. Which case you are doing more work done, guys?
Case
Sir, the
1,
first
sir.
Case 1.
Case 1, sir.
So that is why. So which is better to do? You need to apply the force in 0 angle or less than 90, like with some angle. Which is easy to move the object? I want the answer.
Some angle.
With some angle. That is a relation you should understand. That is why I am always stressing on this much. So this is what the concept you have to remember. If you are applying the force with some angle, it is easy to move the object. Is it right or wrong? Yes, please. That is you have to remember. Now, examples of positive work done. Can you give the examples of positive work done? I want the from your mouth. Examples of positive work done in our daily life. Examples of positive work done, please. For example, you might be noticed in our surroundings and all. Horse is pulling a cart or bull is pulling a cart. Now tell me, is it a positive work done or negative work done? I want the answer. Horse is pulling. If you have taken, for example, this is the bull cart. Now, if this is the horse, you can see it is applying the force. It is applying the force in this direction. Cart is also moving in the same direction. So is it positive work done or negative work done? I want the answer. Harish, Omar, hey, respond, guys. Horse is applying the force in this direction and displacement also in the same direction. Now tell me, is it a positive work done or negative work done? All of you?
Positive, sir.
Positive work done.
Positive,
What you have to remember. So first example, work done by a horse. Very important, guys. Work done by a horse. Mr. Kaushik, respond. Horse in pulling cart. In pulling cart. Now, last 3 chapters, you all studied something. A famous scientist we found in 2nd chapter. What is the scientist's name? Anybody can tell? Who is the famous scientist? Apple story. Who is that man? Newton's. Understanding? Now remember, a ball is moving, falling freely in this direction. Motion is in this direction and gravitational force also the same direction. Now tell me, is it a positive work done or negative work done? I want response from you.
Negative.
Ray, ball is falling, free fall. Ball is falling also same direction, means displacement also same direction. Direction of force also same direction. Now tell me, positive work done or negative work done?
Positive work done, sir.
Positive work done. That is the second example. Work done because both are same direction. Understand, Noor? Nimish? That is work done by the gravity. Please write and draw the image also. Gravity on a body falling towards the earth. Falling towards the earth. Okay. Next. Third example. Now, for example, let me imagine our Omar is standing here and I kept now 10 kg load. Now, Omar is applying the force on this. He is lifting the box. Now, tell me, lifting the box means direction of force and direction of displacement. Both are same direction or opposite direction. From your mouth, I want the answer. Direction of force and displacement. Omar is lifting this box. This is the box. So that direction of force and direction of displacement. So what direction Omar will apply the force, Harish? Harish Jairas?
Up.
Speed. The applying force is upward direction. So Omar will apply the force in upward direction. And displacement also what? He is trying to lift. Is it the box will go down or coming up? Asin Balaji? Danishkar? Arun? Yes, please respond. He is applying the force upward direction. So that box also will move the same direction or opposite direction?
Same direction, sir.
Same direction. So displacement also will be same direction. So is it a positive work done or negative work done? All of you. Positive work done. So work done in lifting a heavy load by a man. Please note down. So these are the examples which I can make for positive work done. Anyone having any doubt, you can ask me, or else complete it fastly. Do it fast. Any doubt?
Sir,
Yes.
sir, in 0 to 90 degree, we are considering 90 degree and 0 degree, yes, sir.
No, Hari, we are considering work done is 90. See here it is a vertical one. That is why you are feeling like that. Basically, if the body is, we are applying the force is 90 degrees, then the work done is 0. When the horizontal surface, remember, body is trying to move like this, and I am applying the force like this. Understand, Hari? Then work done is 0. Are you clear, Hari?
Yes, sir.
Now, in this case, lifting the body, check it. Body is also moving in this direction. Force is also moving in this direction. Then what is the angle between them?
0 degrees.
You understand, Hari? So that work done is equals to F into S. Okay, Mitakshri, Harish, everybody? Now, in this case also, gravity case also, check it. Displacement also same direction, applied force also same direction. Then what is the angle between them? Angle
0, sir.
0. Are you clear? What I'm saying, Hari?
Yes, sir.
So that is you should remember. That is what I'm saying. So whatever it is, we have to check that 0 to 90. It's not come 90, less than 90. Is it okay?
Yes, sir.
So please make it. Clear, everybody? Next. Next, negative work done. Positive work done, any doubt, Mr. Danishkar, Arun Kailash? Negative work done. Never ask us, sir. We will never respond. We want only simply joining and sleeping. That is what will happen. Okay, write it. Harijaras, you understand Harijaras? Negative work done. So can you tell me where the negative work done angle? Anyone can tell me? Negative work done.
90 to 180, sir.
90 to 180 degrees, right? When the angle between the force and the displacement, of a body is obtuse angle. What do you mean by obtuse, Nimish? Obtuse. Before acute angle, now obtuse angle. What do you mean by obtuse, guys? Theta varies from 90 to 90
180.
degrees. Then work done will be negative. Will be negative. In this case, theta is negative or positive? Everybody. Yes, please. Cos theta, negative or positive?
Negative, sir.
Negative. Okay. That is what you have to remember. Now, if you consider if theta is equals to 180 degrees, then tell me cos 180 is equals to how much? Check the tabular column and tell me cos 180 is equals to how much?
minus 1. Minus 1.
Minus 1. So that work done is equals to force into displacement into cos 180. So which is equals to F into S into minus 1. So which is equals to how much, guys? Work done is equals
Minus.
to formula. Work done is equals to formula minus
Fs.
please write it. Minus Fs. Minus Fs. Clear? All of you? Now, so let us draw the diagram, sir, how it will be. So observe very carefully. This is the point A and this is what my object. Okay, so object, this is the center somewhere, the theta actually. So now direction of motion is this direction. Direction of motion is this direction. Motion, okay, displacement. Now the applied force will be from this side. Here I am applying the force. So the angle is more than 90 or less than 90. Everybody verify it. More than 90 or less than 90 angle. Check it, everybody. More than 90 or less than 90. More than 90. So that it is negative work done or positive work done? Yes, please. Negative work done. Okay. Displacement will be like this and applied force is from somewhere. That is what you have to remember it. Do it now. Any doubt? Ask. Now, observe very carefully. This is what is negative work done. Now, in our daily life, we'll find the best example for negative work done. Let me see. Every one of you, you are having a bicycle, you are having a car, you are having a whatever it is, bike or whatever it is. We people will do the negative work done in certain case. Anyone can tell me what case it is? First example, I'll start with that only. Let me see who will say that. Examples of negative work done. Yes, Mitakshri, Harish, Omar. You all people will apply that. When you want to stop, you all people will do it. But what you will do?
Brakes.
Yes, please.
Brake, sir.
Brakes. So if I am applying the brakes, is it opposite to the direction of motion or same direction of motion? I want it. Response from you.
Opposite, sir.
Opposite that. That is what we can stop the things. That is the first thing. So first example is from our real life. When we apply the force, all of you remember retardation. Do you remember the first chapter, retardation? All of you guys? When brakes are applied, that is what? So when the brakes are applied, all of you remember on a moving vehicle, if it is a bicycle or whatever the vehicle, you can see when we are applying the brakes, then work done will be what? Opposite. We are trying to stop the vehicle so that then work done by the brakes is a negative work done or positive work done? All of you. Braking
Negative
force is negative. Clear? Now, all of you observe. Second example. Now, Mr. Let me take now Mr. Danishkar or somebody. Now he is trying to throw the ball upward direction, but direction of force acting what direction? If this is the ball, the motion will be in this direction. Motion is upward direction. But gravity, what direction? Force. Harish? Downward direction. So now tell me, ball is thrown up. So that it is a negative work done or positive work done? Answer.
Negative work done.
All of you join
Negative.
the meeting again. Okay, that is the thing. Work done by the gravity on a ball thrown vertically upwards. Write it. Work done by the gravity on a ball thrown vertically upwards. Can you give me any other examples in your daily life? You can find so many others. Those who are playing cricket, football, volleyball, you all people can also find negative work done. I want the answer. For example, now a ball is coming like this. Check it, everybody. Ball is coming.